Now, in number 13 here, the number of students enrolled at a college is 15,000. So the initial amount of A is 15,000. The percent rate of a change is 4%. And he told me it's a growth, so I'm talking about a growth factor. So I will add 1 to what? To 4%. Here I just fill the blanks. 4%. Now
0.04.
it is 4 over 100. Then how many decimal point? How many digits? Sorry, 2 digits. Then
2 digits.
From here, 4 and nothing, so you have to add 0. So it will be 0, 4. Then the answer is 1.04. This is now the growth factor. Now, to find the number of students enrolled after 1 year, you calculate 15,000 multiplied by what? Here you have
1.04 to the power of x.
0.04 raised to x. Thank you. Complete the equation. You say y is 15,000 multiplied by 1.04. I'm sorry, here after 1 year, so without x, because x is 1. Here, to find the number of students enrolled after 1 year, you just multiply 15,000 by 1.04. After 2 years, you multiply 15,000 by 1.04 to the power 2. After 3 years, to the power 3. After 10 years, to the power of 10. After x years, to the power of x. So the function is 15,000 times 10, times 1.04 raised to x. Then use your equation to predict the number of students enrolled after 25 years.
So we'll write it instead of x, 25.
15. Thank you. Times 1.04 raised to what now? To 25.
To 24. 25, I mean.
25, thank you. So 1.04 raised to 25 is 2.665 multiplied by 15,000. The answer is 87 students. Now, before we go to talk about the exponential decay,
Teacher, there's no sound.
Welcome to another video from Equalizer.com. In this video, we are going to use the Casio FX991ES Plus and the imaginary at the bottom. That I can go to the right to see which we press number 4, A plus BI. So on the screen you see
in electrical engineering, these types of problems are very important. And
now look here. Did you see this one, x raised to a square?
Yes, teacher.
This one, did you see it?
Yes, miss.
Okay.
Which one?
Yes, teacher.
Wait, excuse me, wait a minute, please. Here. This one. Okay, this one. When you press on it, it comes like x raised to a square. Then you have to write 3 as an example. Let's give me the numbers. Like, I'm sorry, it's when you press this one, you can write instead of x with the 3 and instead of the square with 4. So it can solve to me 3 raised to 4. I will describe it, but this is the button. I will describe it later on for you.
But teacher, in my phone, I don't have x to the square thing.
You don't have a calculator?
I have a calculator, but on my phone.
Okay, no, there's a powers in phone. I will tell you also how, but later on. Now, now here, the function y equal a times b can be modeled exponential decay now, not exponential growth, as well as the exponential growth. In both cases, b is determined by the percent rate of a change. I have the same steps, but in the growth, in the growth, you say 1 plus r, but in the decay, you say 1 minus r. These are, this is the difference. In the growth, you say 1 plus r, and in the decay, you say 1 minus r. Now, exponential decay. Exponential decay can be modeled by the function a times b, where b raised to x, and whereas a must be greater than 0, as this previous one, and b here now, it must be less than 1 and greater than 0. I mean, it must be a positive number, but less than 1. The base b is the decay factor, which equals 1 minus the percent rate of the change expressed as a decimal. The same steps, but instead of adding 1, I will subtract it by 1. And the function, it comes like this. Like, my mom gives me at the first day 10 reals. The second day, she gives me 5, half of them. Then she gives me 2.5 reals. Then 1.25. Then 1.325, and so on. So she gives me now a numbers. These numbers are decreased by a time. This one, we called it an exponential decay. They have the same function, y equal a times b raised to x, whereas b is a decay factor and a is an initial amount. Now, identify the initial amount a and the decay factor in each exponential function. Look at me here. Where is the decay factor? It is the number that's raised to x. So it will be 5 or 0.5?
0.5.
Thank you.
0.5.
Thank you. This was my decay factor. Now, as you see here, it is 0.5. Is it less than 1?
Yes.
Yes, thank you.
Yes.
Now, where's my initial amount?
5.
5, thank you. Now, let's go to number 24. 0.1 is my decay factor because it's raised to x, and 10 is my initial amount. Now, state.
Teacher, can you just a moment for the last slide?
Yes.
Okay, thank you.
Now, you are welcome. Now, state whether the equation represents exponential growth, exponential decay, or neither. Look at the first one, 28 now. And 28, y equal 0.93 times 2 raised to x. Now, look at it. Where's the number that's raised to x? It is 2.
2.
Is it greater than 1 or less than 1?
Greater than.
Greater than 1. So, because 2 is greater than 1, so I will say it's a growth factor. So this function will be an exponential growth. Let's talk about now 29. Y equal 2 times 0.68 raised to x. Where's the number that's raised to x? It is 0.68. 0.68. Is it less than 1 or greater than 1?
Less than 1.
It is less than 1. Thank you. So I will name it with
Less.
decay
Exponential
factor.
decay.
This is an exponential. Yeah, thank you. And it is an exponential decay because the 0.68 is less than 1. Now look at number 30. Y equal 68 times x squared. What's that?
Neither. It's a function.
Yeah, neither.
It's a neither. Why? Because it's not an exponential function. It's a
Yes,
quadratic.
it is not. Ah, yes, a quadratic.
Because I must have number base raised to x, not x based to a number. So it's neither, because it's not an exponential function. Now, let's do problem number 3. Modeling exponential decay. The kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. So, at the sea level, it is 101. For every 1,000 meter increase altitude, if I go up, the pressure decreases about 11.5. So, where's my percent rate here? It is 11.5. 11.5, what is the word before it? It is decrease. So I'm talking about exponential decay. Now, so A here, let's relate the function. Y is A times B raised to X. Where is A? It is 101. So Y is 101 times, where's B? I want to find B now, which is my rate, my decay factor. To find the decay factor, it is 1 minus the number. Okay, now I want to find the rate as a decimal. The first point, write it as a decimal.
Miss, it is written as a decimal.
Yes, but if you want to solve it, it didn't give you the numbers as a decimal. I want to show you how. So it is 11.5 over 100. Is it right?
Yes.
Okay. Then, look at me. This is like, it comes like this. And here I have my decimal point. I just want to move the decimal point to be as here.
Multiply.
So I just put it like this. Then, if I move it to the right, I multiply by 10 or just add 0. So it comes as 115 over 1000. Is it clear until now? Until now, is it clear? Okay, then I want to write it as a decimal. So put point, then 3 lines. How many? Why 3? Because here we have 3 zeros. Then take the number 115 and start writing from the right, like 5, 1, 1. So the percent rate as a decimal is 0.115. This is now as a decimal. I didn't finish. I want now after that to try to find the decay factor. I must subtract 1 minus the number that I found before. Then 1.000 minus, put 0 under the digits under each other, then 115. By the way, In my classes, the calculator is forbidden. But because we have an online, you can use it. That's why I want to tell you here, how can you subtract decimals? How can you convert percent to decimal? Because later on, when we will leave the online courses, inshallah, and we will go back to school, you don't allow, or the calculator is not allowed. Clear? So you have to focus on me. How can you find or subtract a number from, or a decimal from a number?
Teacher,
Yes.
the calculator in the test is not allowed.
No.
But teacher, you when we was small, you said that we'll be bigger. We can use the calculator in the test and everywhere.
In my classes, actually in my classes, even you are in grade 10, the calculator is not allowed.
Teacher.
Because in SAT exam, some questions are not asking you, or they are told you don't use calculator. So you have to know.
Okay, but we're still learning.
Okay, but it's not
Still
allowed.
learning.
You must know. No, okay, but these things they not from grade 5. So you have to do it by your hand, without calculator. Can you repeat?
Is this lesson included in that?
Is this lesson what?
Included in the quiz?
No. It will be in the next quiz, inshallah. Now, so after that, 1 minus 0.115, here it will be 10, minus 5 is 5, here it will be 9, 8, 8, so the answer is 0.885. This is now my decay factor. So the function is y equal 101 times 0.885 raised to x. Then, what is the approximate pressure at an altitude of 3,000 meters? Now, here he told me that for every 1,000 meter, it's decrease 11.5. So for every 1,000 meter, it increased. After 3,000 meter, okay, how will be the atmospheric pressure? I will use this function, 101 times 0.885 raised to x. What is x here? Can tell me. Girls?
Yes, teacher. X equals 3,000.
But he start
3,000.
No, equals 3.
Look here.
300 minus 1,000.
For
Suppose 3.
no, they start. Look here. Where is it? They start from the sea level. And that means they start from the 0. They every 1,000 increase or decrease 11.5. So I didn't go meter by meter. I go every 1,000 meter. So after 3,000 meter, what will be x? Or what x will be?
3,000.
I didn't go meter by meter. I didn't walk every one meter. I walk every 1,000 meter. I start from 0. I walk every 1,000 meter.
So it's going to be 3?
It will be 3. Thank you. Because how many steps did I move?
3.
3.
Miss, I didn't understand this 3,000. And they say at the sea level. They mean not from
The sea
1,000?
No, sea level. In science, sea level, it's mean at the 0 meter. They put an what do we call that? Like a measure. As an example, if I told you that Riyadh is 25 meter, they told you 25 meter above the sea level. So they put sea level as a point, as an initial point from where we measure any length or any altitude of any mountain or any place. So the sea level is like 0 in the ruler. So it is 0.
Then teacher, we will make 3,000 minus.
No. He didn't start from. He told you that I start from the sea level. Yeah, I'm start from 0.
Okay.
Okay. For every 1,000 meter increase, the pressure will decrease. So I walk 1,000 meter. He didn't tell me for 1 meter increase, like for 1 year increase. He told me for 1,000 meter. It decreased 11.5. Now after 3,000 meter, so how many steps did I move? 1, 2, 3. So I moved 3 steps. So raised to 3. Then 0.885 raised to 3 multiplied by 101. The answer is 70 point, or approximately 70 thousandths of meter. It's like 70,000 meters.
Okay.
Now, in GOT 3, what is the atmospheric pressure and at an altitude of 5,000 meter now? Not in 3,000. Here now, he told me that you are at the 0 level, and you said every 1,000.
It will be 5.
It's going to be 5.
Thank you. So I move 5 steps. So I just wrote y equal 101 times 0.885, but now raised to the power 5. It is 0.542 multiplied by 101. It will be 54.8 thousand of meters. I'm sorry, not thousand of meters, kilopascal. I'm sorry, the unit here is 70 kilopascal. Because here, as you said now, we said that it starts with 101. If the altitude is increased, the kilopascal will decrease. As you see, it started with 101. If you reach 3,000 meter, it will be 70. If you reached here, it was 101. If you reached 3,000 meter, it will be 70. If you reached 5,000 meter, it will be more and more decrease. So it will be 54.8. That's why we name it as a decay factor. Is it clear?
Yes, teacher, 0.885, it came from the decay factor 1
raised to 5.
Yes,
0.885, yes. It comes from 1 minus the percent rate.
Okay.
Okay, now let's do, I don't know which question actually.
Yeah, I have a question.
Yes.
What is the answer of Gata 3 number 8? Gata 3A.
It is 54.8. This one, the population of city question. It's 27. This is a 27. Now, there's a city, and the population of this city is 45,000. Now, its population is 45,000 people and decreases 20% each year. Decreases. So, I'm talking about decay factor. You have to analyze the question. I will not tell you in the exam it is a decay or it's a growth factor. You have to know. So, the initial amount, A, is 45,000. They start with 45,000 and decrease 2% each year. So, R now is 2 over 100. And I can write it as 0.02. Then, so the decay factor is 1 plus O2 or 1 minus or 1 minus O2?
Minus.
Minus, thank you.
Minus.
And it will be 0.98. So by now I find A, I found B. If the trend continues, what will happen after 15 years? Here is X. It's very easy. I can find X, I can find B, and also I can find A. So Y is equal A times B raised to X. A is 45,000. B, where's B? I found it before. It is 1.02.
0.2.
Raised to X. This is after X number of years. After 15 years.
It is 0.98.
I'm sorry. Thank you, Farah. Now, it is 45,000 multiplied by 0.98 raised to number 15. Now, by calculator, 0.98 raised to 15 is 0.738. Multiplied by 45,000, the answer is 33 times 2, 3, 5 number. So as you see here, the city is at the first time they start with 45,000 number of people in it. After 15 years, and I mean that if you are in 2000 now, in 2015, after 15 years, the number of population is 33.235 people. They are decreased. In this city, they are decreased to be, they started from 45 and it will be 33. Which is greater, 45 or 33?
45.
45. So it started from a big number, then it's decreased to be as 33. So this is an example of decay factor. Is it clear now our lesson today?
Yes.
Yes, teacher.
Do you have any question?
Teacher, do we have homework for
Yes,
this
you have
lesson?
today. Yes, today you have 7 in your practice book. Did when you have the science, is it tomorrow?
Yes.
Okay.
Yes, teacher, it's tomorrow.
Teacher, you didn't put an assignment for lesson 7-6.
For 7-6.
Yes.
Teacher,
The
that
last
lesson you
thing
told
was
us to
7-5.
take a picture. Teacher, that lesson you told us to take a picture of it and then send it to you on email because you forgot to put the place where you were going to attach the photo, the picture.
Yeah, but I sent all the homeworks in your WhatsApp.
Yes.
Yes.
I just
Yes.
I'm telling you that I didn't send the
Until
homework. I
7-6.
made it, but I didn't send it. Of
Send
7,
it. Me too.
6
So now are we done?
assignment.
Okay, today I will make assignment for 7.7, but you will not give me the, I will not ask you to give me the homework today because you have a quiz tomorrow. I will ask you to give me the answers on Tuesday.
Okay.
Okay.
Okay?
Miss, can you tell me
Okay.
what is the answer for 13, the final answer? Because I didn't, y equals 15,000 multiply 1.04 to the power 25. This is, I didn't complete it.
Here?
Yes. Yes, in number,
Okay,
in
take
number E.
Take your time. The others, I finished the lesson today. If you have any question, you can ask me. Please, girls, if you didn't understand anything, ask me before we go to the next question, to the next lesson, sorry.
Teacher, I
There's
understood
not
the
no
decay.
Now
answer.
are we done?
Yes.
Teacher, the only difference between decay and growth is that in growth we add 1 and in decay we minus 1.
Yes. That's it.
And decrease and increase in the question.
Yes, and increase before the rate. If it's increase, it's a growth. If it is decrease, it is a decay.
Okay, thank you, teacher.
You are welcome.
Sorry, miss, but in number A, nothing is written. It is the question only. It's written.
Because when I go, it's cleared. Okay, I will give you the answers. A is 50,000.
Okay.
B is 1 plus 0.04, which equal
1.04.
Yes. And C is 50,000
multiply
by 1.04 only. Because for 1 year. After a number of years, you say it is 15,000 times 1.04, but here now raised to x.
Okay.
And the last one, it is 15,000 1.4 raised to the power 25, and you will find the answer. I think it was 39.988. This is approximately the
To
final
the
answer.
final answer.
Yes.
Okay.
Okay, that's it.
39.
Thank you for listening.
Yes, miss. Thank you so much.
You are welcome. Have a nice day. Good luck for science
Thank you,
Have a
teacher.
nice
Bye.
Bye, teacher.
Bye.
Bye-bye.
Thank you, teacher. Bye.
Bye.